So for number 54, we want to see if the sequence over here, if it converges. Now sequence AN, it converges if AN tends to a defined number, right, a limit as n goes to infinity. And now we aren't given a formula like 49 through 51, so we can't check the limit analytically. And when we look at these terms, it's not immediately obvious what the pattern is or what the limit is, right? It's not obvious like 53 where you look at it and you can tell exactly what the pattern is. So what we're going to have to do here is we're going to have to try to find a general formula so that we can take the limit. And initially it does look a bit disorganized, right? It doesn't really appear very clear what the limit is. But if you look at the odd versus even numbers, something very interesting happens. So in the odd numbers, you have, on the denominator, we have 1, 2, 3, 4, and so on. So the odd numbers appear to increase normally, right? And if you look at the even numbers, they appear to increase normally, but they start at 3. So 3, 4, 5, 6, and so on. So we can see here that there's a pretty defined pattern for the odds and for the evens. So what we're going to do here is we're going to split this into two. So we need a odd and we need a even, right? And so we can't just write odd and even. We need to be able to express even mathematically and odd mathematically. So an even number, that's pretty easy. An even number is just a number that is a multiple of 2, right? So a number is even if you can describe it as a multiple of 2. So that's just going to be a of 2n. So this guarantees that when I plug in 1, it's going to give me 2 times 1. So that's even. When I put in 2, 2 times 2, 4, even, and so on. And now an odd number, it's an even either plus 1 or minus 1, right? So we can either do a n minus 1 or a n plus 1. We can either do 2n, which is even, minus 1, or we can do 2n plus 1. These work out the same. However, let's check where it begins. It begins at 1, right? Since we're evaluating at n is equal to 1, if I plug in 2 times 1 plus 1, it's going to begin my index at 3. I don't want it to begin at 3, I want it to begin at 1 because it begins 1 over 1. And if I plug in 1 here, it's going to give me 2 times 1 minus 1, 1. So actually that is where I want to begin. So that is going to be my a sub 2n minus 1. So all I did here was I'm going to highlight these. So that's my odds and these are my evens. And so if we break this into two parts, we can say that a of 2n minus 1, it just goes 1, 2, 3, 4, 5, and so on. So that's just 1 over n, right? As n increases, so does the denominator. And we can see here that if we plug in n is equal to 1 for the index, right? This is not the value of the sequence, but the index. It's only going to evaluate on the odd indexes. So 2 times 1 minus 1 is a sub 1. 2 times 2 minus 1 is going to be a sub 3. 2 times 3 minus 1 is going to be a sub 5, and so on. So we can see that this clearly matches for our odds. And what about our evens? Well, our evens also increase, but they do so if we begin at a sub 1, it's going to give me actually a sub 2, right? Because 1 times 2 is a sub 2. And a sub 2 is 1 over 3. So it's just n plus 2, right? Because if I'm at if I'm at the second index here, it's just going to be 2 plus 2, which is 4. If I'm at the third index for this even one, it's going to give me 3 plus 5. 3 plus 2 is 5. If I'm at the 4, 4 plus 2 is 6, and so on. And so we can see here that this clearly matches, right? And so it's just to emphasize, the index here gives us the A1, A2, A3, A4, and so on. And on the right-hand side, it gives us the value of the sequence. So once we are here, we can just take the limit. And this limit, 1 divided by infinity, if I take this limit, right, I'm going to go, I'm going to move this to the side. So if I take the limit as n approaches infinity of these, it's going to be 1 divided by infinity, that's just going to be equal to 0, and for the second one, it's going to be 1 divided by infinity plus 2, it's also equal to 0. And so I've shown that both in the cases of the odd and the even indexes, both limits tend to 0. So an tends to 0 as n approaches infinity, so an converges. And that is it for number 54.